Hello everyone. Let us see some more examples based on D'Alembert's ratio test. Examine for the convergence of the series summation n running from 1 to infinity n factorial square divided by 2n factorial into x raised to n where x value is greater than 0. Solution. Here they are given what? Nth term. Now this is very easy to solve by data. Un is equal to given n factorial square divided by 2n factorial into x raised to n. This is our given un. Now un plus 1 is equal to n plus 1 factorial, n changes to n plus 1 factorial whole square into x raised to n plus 1 divided by 2 into n plus 1 factorial. Now we solve this one. It will be what? To n plus 1 factorial square into x raised to n plus 1 whole divided by 2n plus 2 factorial. So denominator it will be 2n plus 2 factorial. Then un plus 1 divided by un is equal to n plus 1 factorial whole square x raised to n plus 1 divided by 2n plus 2 factorial into 2n factorial divided by n factorial square into x raised to n. Here to solve this one you must know the results, some results which are on the basis of factorial. We have some results which are useful to solve this one. I will write here. We know that n plus 1 factorial can be written as n plus 1 into n factorial, n plus 1 into n factorial, and 2n plus 2 factorial can be written as 2n plus 2 into 2n plus 1 into 2n factorial. In previous standards you have studied these results which we are using here. Now use these results here. What we will get? Un plus 1 divided by un is equal to, this one can be written as n plus 1 into n factorial square. X raised to n plus 1 can be written as x raised to n into x into 2n factorial divided by, always your dividing line will be middle of this equivalence. Okay. Now the numerator terms, this one can be written as 2n plus 2. I am taking all these terms in one dividing line only. 2n plus 2, 2n plus 1, 2n factorial, and this is n factorial square. This factorial is only for this 2n factorial into x raised to n. Okay. Now if you want, take this one like this. Now I simplify this one. This will be n plus 1 whole square n factorial square this x raised to n cancel with this one, and this 2n factorial cancel with this 2 raised to n factorial. The remaining is only x divided by 2n plus 2, 2n plus 1 into n factorial square. Now this n factorial square cancel with this one. Our remaining un plus 1 is what? N plus 1 whole square divided by 2n plus 2, 2n plus 1. This is what? Un plus 1 divided by un. Now limit n tends to infinity, un plus 1 divided by un is equal to limit n tends to infinity. In these terms I will take n common. It will be n into 1 plus 1 by n. Sorry, it will be n square since we have a square here, and from this to n into 2 plus 2 by n into n into, here I am taking one step direct, here 2 plus 1 by n. This n cancel with this n square, and simplify this one. The remaining terms are limit n tends to infinity, 1 plus 1 by n whole square divided by 2 plus 2 by n into 2 plus 1 by n. Here I forgot to write x here. This x remains same in all the terms, into x into x into x here also. Now apply the limit here. 1 by infinity is 0, 2 by infinity is 0, 1 by infinity is 0. Therefore it will be 1 into x means x divided by 2 into 2 means it is 4. Limit n tends to infinity, un plus 1 divided by un is equal to x divided by 2. Therefore our conclusion will be, thus by ratio test, summation un is convergent. I will write in short convergent, but you have to write the whole term as a convergent. X by 4 is less than 1 or x is less than 4. Divergent if x by 4 is greater than 1 or x is greater than 4. And test fails if x by 4 is equal to 1 or x is equal to 4. This is our conclusion. Okay. If you don't know the results based on factorials, just go through the previous class, previous standard test books. First PU, second PU, you will get these results, how we get these results. And remember those results which are very helpful for solving the examples. For this example, we get the limiting value is x by 4 and we don't know the value of x, so that we have to write the conclusion like this, that is convergent if x by 4 is less than 1 or x is less than 4, and x by 4 is greater than, when x by 4 is greater than 1, the series will divergent if x by 4 is equal to 1 or x is equal to 4. This will be fails for this given series. Test will fail for the given series. Next example, find the nature of the series. square root of 1 by 2 into x plus square root of 2 by 3 into x square plus square root of 3 by 4 into x cube plus and so on. On seeing this series, we have to first write the nth term of this given series. Solution. Observe this series. Here the numerator terms are 1, 2, 3 and denominator terms are 2, 3, 4. And here x powers are from 1, 2, 3 and so on. See, when we take n is equal to 1, as I say in earlier classes also, if you are taking one assumption as a un, just you have to verify whether that satisfy all the terms of given series or not. See, when we take n as 1, it will be 1 x raised to 1. Okay, when n is equal to 2, it is 2, 2 square, 3, 3 square. But for the denominator term, for the first term, the value of n is what? 1. If you take n is equal to 1, this will be what? N plus 1. Here for the first term n is 1. When we take n plus 1, it will be 1 plus 1 is 2. For second term, it will be n is equal to 2. When we take it as n plus 1, 2 plus 1 is 3. Okay. Therefore, our un term is what? Let un is equal to square root of n divided by n plus 1 into x raised to n. X raised to n is outside the root. Then therefore un plus 1 is equal to square root of n plus 1 divided by n plus 1 is n plus 2 into x raised to n plus 1. This is our un plus 1. Now un plus 1 divided by un is equal to, square root of n plus 1 divided by n plus 2 into x raised to n plus 1 into square root of n plus 1 divided by n into 1 divided by x raised to n. This is our un plus 1 divided by un. Solve this one. Here this one x raised to n cancel with this x raised to n. Take for easier calculation, I will write these terms as square root of n plus 1 into square root of n plus 1 divided by square root of n plus 2 into square root of n into x. Okay, we know that root n into root n is n. Therefore, it will be n plus 1 because since root n into root n is equal to n, in place of n we have n plus 1, therefore it is n. This is n plus 1 divided by, this can be written as square root of n into n plus 2 into x as it is, which is un plus 1 divided by un. Then limit n tends to infinity, un plus 1 divided by un is equal to limit n tends to infinity, n plus 1 divided by square root of n into n plus 2 into x, which is equal to avoid the infinite quantity, I will take n common, 1 plus 1 by n divided by, in this 2 term I will take n common here from this one and from this one, it will be n into n square. N into n is n square. N square, otherwise I will write another step, n, and from this term I will take n common. N into 1 plus 2 divided by n, 1 plus 2 by n into x. N into n is n square. When we take this n square outside the square root, it will be simply n. N into 1 plus 1 by n divided by n into square root of 1 plus 2 divided by n into x. N get cancelled. Now apply the limits. It will be 1 plus 0. 1 plus 0. Square root of 1 is 1. 1 into x is x. Therefore it is x. Un plus 1 divided by un. This is limit. N tends to infinity. Un plus 1 divided by un is equal to x. Similarly, conclusion we have, thus by ratio test, summation un is convergent if x is less than 1, divergent if x is greater than 1, and test fails if x is equal to 1. This is how we have to solve the examples which are given in a square root. Next example, find the nature of the series 1 divided by 2 into root 1 plus x square divided by 3 into root 2 plus x raised to 4 divided by 4 into root 3 plus and so on, where x value is greater than 0. First we have to identify what will be the nth term of this given series. On seeing this series, here in the first term we don't have any value of x, but in the remaining term we have the x term here. In this case we have to omit the first term here, so that omitting means omitting the first term, the general or the nth, the general term of the series is given by un is equal to, consider here value of n is 1, 2, means x raised to, I will take it as a 2 into n, because we have here the x powers are multiple of 2 here, so that we have to take x raised to 2n divided by, when x value is 1, for this one it will be what, here we have 3 here, so it will be n plus 2. When it is x, n value is 1, 1 plus 2 is 3, square root of n plus 1. This is our un. Now un plus 1 is equal to x raised to 2 into n plus 1 means it is 2n plus 2, I will write directly, divided by n plus 3, n plus 1 plus 2 is n plus 3 into square root of n plus 2. This is our un plus 1 term. Now also un plus 1 divided by un is equal to x raised to 2n plus 2 divided by n plus 3 into square root of n plus 2 into the un term n plus 2 into square root of n plus 1 divided by x raised to 2n, which is equal to, for our easier calculation, I will write like this. Write the root terms in one side. This is n plus 3. This x raised to 2n plus 1 can be written as 2n into x square. This is x raised to 2n into square root of n plus 1 divided by n plus 2. Now this 2x raised to 2n plus 1, x raised to 2n, x raised to 2n get cancelled. Remaining is x square into n plus 2 divided by n plus 3 into square root of n plus 1 divided by n plus 2. This is our un plus 1 divided by un term. Now limit n tends to infinity, un plus 1 divided by un is equal to limit n tends to infinity x square into n plus 2 divided by n plus 3 into square root of n plus 1 divided by n plus 2. Now to avoid the infinite value after applying the limit, I will write like this: x square as it is, take n common, it will be n into 1 plus 2 by n divided by n into 1 plus 3 by n. Here also I will take n common, 1 plus 1 by n divided by n into 1 plus 2 by n, which is equal to limit n tends to infinity, n get cancelled, this n get cancelled, x square into 1 plus 2 by n divided by 1 plus 3 by n into square root of 1 plus 1 by n divided by 1 plus 2 by n. Now apply the limits as n tends to infinity. 2 by n is infinity, 2 by infinity is 0, 3 by infinity is 0, 1 by infinity is 0, 2 by infinity is 0. So that we get x square into 1 plus 0, 1 plus 0, 1 plus 0, 1 plus 0. 1 by 1, square root of 1 is 1. Therefore, we get it as x square, because 1 plus 0, 1 plus 0, 1 by 1 into x square is 1. 1 by 1 again into 1 into x square is x square. Therefore, limit n tends to infinity, un plus 1 divided by un is equal to x square. This is our limiting value for this given series. Thus, conclusion, thus by ratio test, summation un is, I will write in short, convergent if x square is less than 1, divergent if x square is greater than 1, and test fails if x square is equal to 1. This is our conclusion. We have to highlight this one. These are the some example based on D'Alembert's ratio test. For every example, you have to highlight your conclusion while you are writing the examination. For this example also. Now come to the homework examples. Find the nature of the series 2 by 3 plus 2 3 divided by 3 5 plus 2 3 4 divided by 3 5 7 plus and so on. They are given series. You have to write what will be the nth term of this given series. First you have to write the un for this given example. First write un. Okay, and this example is same as the fourth example which I have solved in lecture 5, but in that example just they are given extra x term. Here x term is not there. Just avoid that x term, you will get the un term. Before that, first you have to understand the fourth example, then you will go through this example, you will get the required result. Okay, next example. Find the nature of this series summation n running from 1 to infinity 4 7 10 so on to 3n plus 1 into x raised to n divided by n factorial, where x is greater than 0. Here the condition is given, that is x is greater than 0. Here not necessary to find the un because they are already given the nth term of the series, that is summation n running from 1 to infinity 4 7 10 so on 3n plus 1 divided by n factorial whole term into x raised to n. Just find by data, write what will be your un, then write un plus 1. Here also the results on factorials will help you to solve this one. Okay, now you have to use those results. First write un, then find what will be your un plus 1. After that go through the un plus 1 divided by un. Then while writing un plus 1 divided by un, just take the previous term of un plus 1 in the numerator just to cancel the terms. Okay, then if you get any term which will gives us an infinite number, just avoid that by taking the n number as a common in those terms, then cancel the n terms and find what will be your limiting value, then write the conclusion by ratio test. Write all the notes to lecture 6. From this we complete the first half of your fourth modulo, that is first half of fourth modulo is series of positive term, convergence and divergence is over, Cauchy's root test is over, D'Alembert's ratio test and illustrative examples on these two tests are over. In the next class we will see the next part of this fourth modulo. So that before going to this second part, you have to must write all the notes and understand all the concepts. If you have any doubt, we will see in the live classes, and all of you must solve these two examples.